Hey everyone, welcome back to Quant Prof. Today we're going to solve a Point72 quant interview question. Check the description for more quant interview resources. Let's look at the problem. Three legs are positioned uniformly and independently on the circumference of a circular table. What is the probability the table will stand? Note that the table will stand when the center of the circular table falls within the triangle formed by its three legs. So the problem can be reframed as, what is the probability that the center of the circle lies within the triangle formed by the 3 points? Pause the video here if you want to give it a try. Let's look at the solution. Without loss of generality, we can fix the first point. Let C be the circumference of the circle. Let X represent the distance between the first and second dot along the minor arc of the circle. Note that X varies between 0 and C by 2 as the distance is measured along the minor arc. For the center of the circle to be inside the triangle, the third point must lie on an arc of length X, opposite to the center as shown. Therefore, if the distance between the first 2 points is x, the probability that the center lies inside the triangle is x over c. This is because the favorable arc for the third point has a length x, while it can be placed anywhere along the total circumference c. Now let's calculate the probability density function of x. First, let's find its cumulative distribution function. What is the probability that the distance between the first 2 points is less than or equal to x? For this, the second point can be positioned within a distance x on either side of the first point. So the favorable arc for the second point has a length 2x. Hence, the cumulative distribution function of x is 2x by c. By differentiating the cumulative distribution function, we obtain the probability density function as 2 by c. Using the law of total probability for the continuous case, the probability that the table will stand is given by this integral. Evaluating this integral gives us the final answer of 1 by 4. Let's consider another problem. We have a 5 cross 5 grid, so there are 25 squares. We can color some of these squares. For example, we can color them like this, or like this. There is one constraint. No 4 colored squares should form the corners of a rectangle with sides parallel to the grid. For example, this coloring is invalid because these 4 squares form the corners of a rectangle with sides parallel to the grid. On the other hand, this is a valid coloring. So, what is the maximum number of squares that can be colored while ensuring that no 4 of the colored squares form the corners of a rectangle with sides parallel to the grid? If your answer is X, you need to create a valid configuration with X colored squares, and also prove that there are no valid configurations with X plus 1 or more colored squares. Try to solve it on your own. Hope you liked the video. If you want to learn how to solve these kinds of interview problems, we invite you to check out our course Quant Interview Masterclass, where we teach you how to think when solving difficult problems. We also cover the entire theory specifically tailored for quant interviews, along with over 1,000 problems. Thanks for watching and see you next time. Until then, Godspeed.